Welcome back. In this video, we're going to study the surface area of circular solids. Recently, we've taken a look at prisms, and there are some similarities between the surface area of prisms and circular solids, except now we're going to be working with, well, things like cylinders and cones, things with circles in them. So kind of like a pyramid or kind of like a prism. So a cylinder is one of the things we're going to be working with, and it is made up of two congruent circular bases. Kind of like the diagram we have here or this particular cylinder, any can that you might have. And the lateral area of our cylinder, think the lateral area of a can. Okay? The lateral area or the outside of our cylinder. Okay, so if I wrapped a piece of paper around my cylinder here, okay, and open it up, that would be the lateral area of my cylinder. And then my circular bases, I would add the area of those to come up with my total area of the cylinder. One thing to keep in mind, though, the lateral area of a cylinder, the formula for that is the circumference times the height of the cylinder. Well, that sounds odd because circumference is circle, is part of a circle. That's what it is around the outside of a circle. That's the perimeter of a circle. So if I had the label on my can, something like this, well, if I pull my label off, this distance around is my circumference. This is my height. I pull my label off, and what do I have but the circumference times the height, which is really a rectangle, length times height. So that is the lateral area of my cylinder. It's length times height, but my length is the circumference of the circle. Which means then my formula for my lateral area will be 2 pi RH, or diameter times pi, plus the area of my two bases then makes up my total area, my two bases of pi times radius squared. So that would be the total area of my cylinder. So if I had a cylinder with a radius of 4, well, my circumference then would be 8 pi. And let's make the height 10, something pretty easy. So my lateral area would be 10 times 8 pi, or 80 pi units squared. And then the area of my two bases are 2 times 4 squared pi, 2 radius squared pi, two bases, 16 pi times 2, or 32 pi. That'd be the area of the base. So my total area would equal 80 pi plus 32 pi, so 112 pi units squared for the total area of this sample of a cylinder. Now, a cone resembles a pyramid, but it's a pyramid with a circular base. So here's your cone. I've got a base that is a circle, looks just like a pyramid, but a circular base. Well, the lateral area of a cone, that's going to be a little tougher. Okay? You can't just wrap something around there That's not going to work out so hot. Okay? So we'd have to do a little calculus to figure that out. But our lateral area of the cone, the area that the label would be 1/2 the circumference times the slant height. Well, what's the slant height? Okay, the slant height of our cone is this height along the outside, labeled L. And the cone has an altitude extending from its vertex, just like a pyramid does. And it forms a right angle with the base. So if we had, if I gave you the radius or the altitude, we could do our Pythagorean theorem to find our slant height. So here's a sample problem to find the total area of a cone. Let's calculate the total area of a cone that has a radius of 5 and an altitude of 12. So the radius of my cone is 5 and my altitude is 12. Well, then I know my slant height L will be 13. I've got a 5, 12, 13 right triangle made up of the radius, the altitude, and my slant height. So I know my lateral area then will be the 1/2 the circumference times the slant height. So using the information I have with a radius of 5, I have a diameter of 10, so the circumference of my cone is going to be 10 pi, so 1/2 10 pi, times 13, my slant height. 1/2 of 10 is 5, so 5 pi times 13. 5 times 13 is 65, so I have a lateral area of 65 pi. But I want the total area, so now I need to add the area of the base, which is just the one circle with a radius of 5. So the area of my circle is 5 squared pi. So plus 25 pi, and 25 pi plus 65 pi gives me a total of 90 pi units squared. Our final formula for surface area, without proof, I won't do a sample problem or anything with that. Well, I could probably do something really quickly. I should say that is the surface area of a sphere. A sphere is just a round ball, if you will. Okay, a basketball, a pool ball, any kind of sphere, a baseball. So our surface area of that, what we could wrap around that particular sphere, the area formula is 4 pi r squared. Once again, we need to do some calculus to prove that. So if I have a sphere with a radius of, say, 5, so we have 4 times pi times 5 squared. So we get 4 times 25 pi, or 100 pi units squared. So the surface area of a sphere with radius 5. And we'll get more practice with this type of thing, and we'll be working with half spheres and that kind of thing as well, and add some challenge to these problems when I see you in class.